All right, everybody, here's number 5. It says, given the data in Table 1, predict the mean number of credit cards, or the average number of credit cards, any adult could be expected to have. So in our table, on the left, we have the number of credit cards listed from 0 to 10. And then on the right, we have the relative frequency for each of the number of credit cards. So to find the expected value, we simply take the number of credit cards and multiply it by its relative frequency. So in other words, 0 credit cards occur 26% of the time. 1 credit card occurs 17% of the time, and so on. So we multiply 0 times 0.26 plus 1 times 0.17 plus 2 times 0.12 plus 3 times 0.10, and so on. All of this is written out over here on the left. We went from 0 all the way to 10, multiplying the number of credit cards times its relative frequency. And when we calculate all of this, we get 2.91. So that means approximately on average 2.91 credit cards we could expect for any adult, which is almost 3. So each adult would be expected to have 3 credit cards. All right, number 6. This is the world-famous gambler from Philadelphia, Senor Rick, proposes the following game of chance. You roll a fair die. If you roll a 1, then Senor Rick pays you $25. If you roll a 2, Senor Rick pays you $5. If you roll a 3, you win nothing. If you roll a 4 or a 5, you must pay Senor Rick $10. And if you roll a 6, you must pay Senor Rick $15. Is Senor Rick crazy for proposing such a game? Create a probability distribution table and explain. All right, so let's look at all the outcomes. Let's starting with the highest outcome. The highest winning would be $25 if you roll a 1. All right, so if you roll a 1, you're going to win $25. So that would be rolling a 1 has a probability of 1 out of 6. Now the next highest prize is winning $5. You win $5 if you roll a 2. Well, that can occur 1 out of 6 times. So winning $5 has a probability of 1 out of 6. Well, the next winning is actually winning nothing. Winning nothing. So that would be an earning of 0. And you earn nothing if you roll a 3. And rolling a 3 has a 1 out of 6 chance of occurring. And then if you roll a 4 or a 5, you have to pay Senor Rick $10. So that means you're going to be losing 10, which is negative $10. And that can happen if you roll a 4 or a 5, which is 2 options out of 6. And then finally, if you happen to roll a 6, you have to pay Senor Rick $15. So that's going to mean that you're losing $15 if you roll a 6. So that's negative 15, and rolling a 6 happens 1 out of 6 times. Computing the expected value, multiplying the outcome value times the probability, 25 times 1 over 6, plus 5 times 1 over 6, plus 0 times 1 over 6, minus 10 times 2 over 6, and then minus 15 times 1 out of 6. When you do the calculation, you end up with negative 83 cents. What does that mean? It means that every person that plays the game would be expected to lose would be expected to lose 83 cents, which means that Senor Rick knows that he's expected to gain 83 cents for every person that plays. So, Senor Rick proposed a good game for himself because he is expected to make money. He's expected to make 83 cents per person. All right, here is number 7. You pay $5 to play the following game of chance. There is a bag containing 15 tokens. 6 are pink, 4 are orange, and the rest are white. You take 1 token from the bag. You win $10 if you draw a pink token, and you win $5 if you draw a white token. How much do you expect to win or lose when playing the game? Create a chart and show your calculations. All right, so here's our probability distribution. All right, so what are the outcomes? Well, you could win a net of $5. Now, I say a net earning of $5 because you pay $5 to play, but you could win 10. So this is actually, if you paid $5 and won 10, your net earning would be $5. So we have 5 here. And you can win that by picking any of the 6 pink tokens. So that would be 6 out of 15. Now, the second option is that you would break even. And how do you break even? Well, you would have to pay $5 to play, and then if you draw a white token, you would win $5. So that means you would just get your $5 back, and your net earning would be 0. So, how many white tokens are there? There are 5. Okay, so the rest are white. So, and how do we get that? Well, there are 6 pink and there are 4 orange. 6 and 4 makes 10, and because there were 15 tokens altogether, subtracting 10 from 15 leaves you with 5. So that means that there must have been 5 white tokens. So that probability of picking a white token is 5 out of 15. And then finally, the last option is that you pay your $5 and don't win anything. So that means that would be a -5 loss, or you would be losing $5. So that's negative. And that would be 4 options out of 15. And that means if you just picked any of those 4 orange tokens, you would not win anything. So that's 4 out of 15. All right, expected value is outcome times probability. 5 times 6 over 15. And then add 0 times 5 over 15. And then subtract 5 times 4/15. And then when you do all of this calculation, you end up with positive 67 cents. So this is your expected earning. All right, so you would expect to come out positive if you played this game. Number 8, at a half marathon race, you have a probability of 1 out of 30 of coming in first place, a probability of 1 out of 20 or 1/20th of coming in second place, and a probability of 1/5 of coming in third place. First place pays $500 to the winner, second place pays $300, and third place pays $100. Is it worthwhile to enter the race if it costs $50? Create a chart and show your calculations. All right, the first outcome is if you won $500, but because you paid $50, your net earning is $450, and that would occur. That would have a probability of 1 out of 30. The next second place earning is winning $300, but when you subtract the $50 to enter the race, your net earning is $250. And that happens 1 out of 20 times. Then the last option is if you win third place, you get $100, but subtracting the $50 that you had to pay, that would be a net earning of $50, and that happens, that gives you a probability of 1 out of 5. And then, of course, if you do not come in first, second, or third, then you simply will have lost your $50. So that's a -50 outcome, and that would happen 43 out of 60 probability. Now, where are we getting the 43 out of 60? Well, you take the first three probabilities, 130, 1 out of 30, 1 out of 20, 1 out of 5, and over here you add those three fractions, and of course when you get your common denominator, which would be 60, you would end up with 17 out of 60. Now, so then the probability of not winning anything would simply be 1 minus 17 out of 60. And of course, 1 is equivalent to 60 out of 60. So you would take 60 out of 60 minus 17 out of 60, and that leaves you with 43 out of 60. So once again, you take 60 out of 60 minus 17 out of 60, and you got your 43 out of 60. All right, expected value is 450 times 1/30th plus 250 times 1/20th plus 50 times 1/5, and then minus 50 times 43 over 60. And that comes out to be $1.67. So is it worth it? Well, since you stand to earn $1.67, it is worth entering the race. All right, here's number 9. A player rolls a die and receives the number of dollars equal to the number on the die, except when the die shows a 6. If a 6 is rolled, the player loses $6. Create a probability distribution chart and determine what the cost should be to play. All right, so we have our chart here. The outcome is, okay, if I roll a 1, I'm going to be winning $1. So that happens 1 out of 6 times. If I roll a 2, I'll be winning $2. That's 1 out of 6 times. If I roll a 3, I'll win $3, 1 out of 6 times. And if I roll a 4, I win $4, 1 out of 6 times. If I roll a 5, I win $5, 1 out of 6 times. But if I roll a 6, I'll be losing $6. So that would be negative 6, and that happens, or could happen, 1 out of 6 times. Expected value, multiplying 1 times 1 out of 6 plus 2 times 1/6 plus 3 times 1/6 plus 4 times 1/6 plus 5 times 1/6 minus 6 times 1/6, and that final result is $1.50. And so then to determine what the cost should be, if I am the game creator, I know that I need a cost that's going to exceed $1.50 in order for me to make money. So the cost should be something greater than $1.50. And any reasonable amount would work. $2, $2.50, $3, whatever. As long as it's greater than $1.50, it would make sense. All right. And that concludes all of the problems that are on the review.